So now, here we have a 555 timer. As long as it is bright enough, we have a high output. So you can see that gives a high input to pin 4. You know, you got to get really close to 0 volts, pin 4, to give a low input where it forces the output actually over there low. We have pin 2, 10K resistor, value doesn't matter right there, to the negative supply. That's over here. So that it's going to the negative supply. That's telling pin number 2 to set the output high. The more powerful pin though is pin number 4. So if you get it dark enough, that gives a low enough voltage to the reset pin, pin number 4, to force the output low. So it's a fight between those two pins, but the reset pin always wins. Now, we got the high output, positive supply, lights a red LED. In this case, it also turns on a NPN bipolar junction transistor. Somewhat low value resistor there because we're going to go a bit low in voltage. When the output is low, blue LED lights up because, again, to pin 1, because it makes a pretty direct connection to ground. That's the secret to this circuit. Makes a really good connection to ground, not so good connection to the positive supply when the output is high. So we got 4.2 volts right there, and we're losing some voltage at the output. You'll notice that the LED is brighter, and we will slowly lower the voltage. This is like a lithium ion cell that is discharging, and there you can see by the time it gets to 3 volts right there, which is actually when you should probably stop using the cell anyways, but you can see that LED turned off completely right there. So the main takeaway with this was that at lower voltages you can't really use the 555 timer for a high output. It works pretty good still with a low output. I can't remember if I showed that at all. So I can turn the lamp off too, of course. But yeah, there we got the blue LED, or just cover it with my finger. However dark, lamp is dimmest setting right there, actually. So it's a little easier to see that LED with the dimmer setting. We'll leave it there. But yeah, that's the main takeaway right there, 3 volts. And normally I limit, when I got LED circuits, 20 milliamps of current, but here we have the potential for 2 LEDs to light up. Not a problem right now, but when I get to 4.2 volts, I mean, there we got 15 milliamps of current. Actually, I had it higher before, so that must have been when I had 5 volts, yeah. 5 volts, we get above 20 milliamps current. So that's why I did that. I thought maybe I changed it after I tried powering with 4.2, but it was 5 volts. So actually don't need 30 milliamps current, but it doesn't really hurt. Even if we pass 30 milliamps current through one LED, not good for it, but probably won't fry it, and maybe it'll work all right for a while. But in any case, there we got it. Protecting the red LEDs with 220 ohm of resistance, but again, if we don't have enough supply voltage, only 3 volts right there, that's not enough to light the LED. So 555 timer is a single supply integrated circuit right there. And that usually means the output does not connect to the positive supply very good, but does connect to the negative supply really well. If it connects to both supply voltages, high versus low right there, that's called rail to rail. And then there's split or dual supply integrated circuits. Their output actually doesn't reach either voltage. They're mainly intended for just middle ground voltages, and so not going to go into great detail on that. In fact, I mostly focus on these single supply circuits. So that's the main takeaway. The only thing is to always be aware of what the output can do, no matter what. So that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.